And welcome, ladies and gents, to lesson 12, 3b, kind of an additional lesson to the third section in the chapter, inequality word problems for today. Go ahead and pause, take a look at your answers from yesterday's assignment. Come on back when you're ready. And so our goal is to take everything that we've learned to set up and solve inequalities of real-world problems. Let's go ahead, if you wish, make some notes. I would suggest that you get out a piece of paper for these key clue mathematical words. So when you're ready, pause the video, put these words into their proper place, and then come on back and you may self-check as I put them in place. Now for each of these words, I might suggest just pick a number and fill it into the blank. So for instance, at most 20 means it can equal 20 or it can be smaller than 20. So then immediately we can see that at most is going to be less than or equal to, and we'll put the at most in that blank. If it says at least 20, then 20 will work and higher will work. So at least is going to be greater than or equal to. Fewer than 20 means 30 is no good, 20 is no good, but 19 is good, 18 is good. All the numbers smaller or less than 20 will work. On the flip side, more than 20, again, 20 doesn't work. 20 is not more than 20, but all the numbers greater than will. A maximum of 20 means 20 does work, and it can also be smaller. To have a maximum, it can be less than or equal to, which means minimum is going to be the opposite. If you need a minimum of $20, then it can equal $20 or it can be larger than $20, greater than or equal to. No greater than 20 means 20 will do, but can also be smaller. It just cannot be greater. So we're talking another less than or equal to expression. Above 20, you guessed it, it's got to be greater. Smaller than 20 is going to be less. Now think about it. If you want a number smaller than 20, then 20 is no good, so it cannot be equal. Larger than 20. How about, okay, less than or equal to, that one seems pretty obvious, huh? Greater than or equal to, seems pretty obvious. Greater than 20. Less than 20. How about this one? No less than 20. Well, if it cannot be less than 20, it can equal 20, and it can be higher than 20. So no less than is another word for greater than or equal to. No more than 20 means it can be 20 and it can be smaller. It just cannot be greater. Therefore, we're talking another less than or equal to phrase. And naturally, below 20 is going to be less than that. So I'll put it on the next page in different colors so you can see the colors kind of stand out. So check yourself, make sure you have the proper words in the proper blanks. And we will now use those clue words to solve problems. Anytime I get to a problem today, ladies and gents, go ahead and pause the video, read it on your own for those of you like me that would prefer to read it on your own, and then come on back. Example 1. Your weekly base salary is $150. That is a base salary. Earn $20 for each cell phone that you sell. Write and solve an inequality that represents the number of cell phones you must sell to make, at least, there's the math keyword, key phrase, $630 in a week. Now, for today, I'm going ahead and defining the variable for you, but really students with those skills should be able to say, okay, let X or C be, what are we looking for? We're looking for the number of phones needed to sell at least 630. So you should eventually have this skill on your own. All right, now to write these, I often ask myself a simple question, or a series of questions, I should say. What do we start with? What happens first? What happens next? In this case, we start with $150. Then we earn more money. How much more money? Well, $20 for each cell phone. But that's not just 20, that's 20 and 20 and another 20, and we don't know how many 20s. So in order to write that mathematically speaking, we're going to write 20 times C. Now you may write the dot or you may not write the dot, but that means 20 for each individual phone, but that number of phones is missing. Now, keyword at least, which means it can be more than 630. It can also be exactly 630. And that, folks, I think is the hardest part of the lesson, to take the verbal sentence and create a mathematical sentence. In other words, take the words and turn it into math. From here, we're going to go ahead and solve. Now, I'm going to use the commutative property to switch the order because that's a positive 150. I'm going to rewrite it as 20 C's plus 150. Let's get rid of that 150. And naturally, anytime you add or subtract, it never changes the inequality symbol. In this case, 150 negative 150 cancel out, leaving us with 20 C's greater than or equal to 480. But naturally, if we want to isolate the variable, we're going to divide both sides by 20. Noticing that when we divide by 20, the inequality sign does not flip around. It is a positive 20. So in this case, C is greater than or equal to, you can go ahead and simplify or reduce by 10 to make your division easier. And then I got to squeeze in a sentence somewhere. Now you can write this sentence in a number of ways. I'm going to say 24 or more phones to earn at least $630. But to be clear and emphasize this, you could have written at least 24 phones. You could have written no less than 24 phones. In fact, students with the strongest skills can write that with numerous different inequality word phrases. So, final inequality, or should I say initial inequality, final answer should be a sentence answer describing what this means. If you go to here, great, but that doesn't convince me that you understand what the answer to the problem is. So pause, rewind if you need, otherwise let's go on. Technology Club trying to raise $1,000, raffling some cornhole boards. I'm not really sure I care what they're raffling. Already made $100. If they sell tickets $5 each, the question, there it is, how many more tickets to make more than, oh, there's that inequality word phrase. So I've already established what the variable is going to be. We're going to use t. If you want, you can always pause, read it to yourself, try to work it out, come on back when you're ready. So we don't start with, okay, remember the series of questions Mr. Callan's going to suggest to you. What do we start with? What happens first? What happens next? We don't start with 1,000 just because that number's first. That actually will be our ultimate goal. What we do start with, it says we have already made $100, and then if we're going to sell tickets, we're going to earn more. So what do we start with? $100. What happens first? Well, we earn more or add money on top of that. What happens next? Well, we get $5 for each ticket, and as we said, we don't know how many tickets, so how can we write that mathematically speaking? We're going to write 5 times T tickets. To make more than $1,000, you cannot be exactly $1,000. So there, ladies and gents, is what Mr. Cowan feels is the toughest part of the problem. Let's go ahead and solve. I'm going to rewrite it. 500 plus 5t plus 100, and then we know we want to get rid of that 100, so you can add a negative or simply subtract. In this case, positive 100 and negative 100 cancel out, which is lovely because that leaves us with 5t greater than 900. Of course, we want to solve, get rid of the 5, so let's divide by 5 on both sides. And because it's a positive 5, the inequality sign does not flip around, which leaves us with t is greater than 180. Let's go ahead and write a sentence. While that's a good answer, it's not a great answer. Now that tells us what we are talking about. Key mathematical phrase I chose was more than, but as you can see from your previous notes, there are a number of different ways to write that. So if they sell 181 tickets, they're good. If they sell 300 tickets, they're good. If they sell 5 tickets, not so good. And even if they sell exactly 180, that's not going to help them get more than $1,000. Onward we go. If you wish, pause, come on back when you're ready. RV Park receives $300 per month from each residential site. In other words, if you plop down your RV, and many people own their own residential vehicles or RVs, of course, if you park it there for a month, you're going to pay $300. They also further get $2,000 per month from their campsites. Write and solve, inequality. What are we trying to find? Find the number of residential sites that must be occupied to make, at minimum, there's our key inequality word, $14,000 in each month. So because we're looking for the number of residential sites, that's why we're going to do R. All right, what do we start with? What happens first? What happens next? RV Park receives $300 per month, but the per month is not as important as per the each residential site. So one residential site, two residential sites, 3, and so on. How do we write 300 for each R site? We're going to write 300 per R. Again, if you wish, you're welcome to write the multiplication symbol. In addition to that, so what do we start with? 300 per R. What happens next? We get $2,000 each month for the campsites. Now notice I'm not writing times M months. We're essentially just talking about 1 month. So 300 times R in that month, 2,000 in that month. The 2,000 is a constant term. Now, a minimum of $14,000 means it can be more than, it can be exactly, but it cannot be smaller. And therefore, most important part right here, let's go ahead and solve. So we want to get R by itself. The first thing we'll do is say, hey, the campsite has nothing to do with the residential sites. So let's get rid of that $2,000. In so doing, a positive 2,000 and negative 2,000 make 0, leaving us with 300 per residential site, $12,000 of revenue. But of course, we don't want 300 per site. Let's split up both sides into $300 sites. Noticing when we divide by 300, it is a positive, and therefore does not flip around our inequality sign. Go ahead and reduce by 10, or should I say 100, to make your division a little easier. And 120 divided by 3 is 40, which means the park must, let's see here, the park must rent out 40 or more, maybe I'll say at least this time. So while that's a good inequality, this is really what tells us the answer to our question. The park must rent out at least 40 residential sites to earn a minimum of $14,000 every month. How about that H, huh? Again, I chose to use the word phrase at least, but surely you can figure out a different way. You could have said 40 or more. You could have said no less than. So there's a number of different ways to write this. Hey, this will be my last example, ladies and gents. Pause and read it on your own if you wish. Animal shelter, fixed weekly expenses, $700, that's every week, all right? Each animal costs additional $6 a week. During the winter months, weekly expenses at most, there's a word phrase, at most $900. Write and solve inequality. Number of animals the shelter can hold to be at most $900 per week. So, because we're looking for the number of animals, let's go ahead and say A is the number of animals that the shelter can hold and pay at most $900 a week. Here we go. All right, so what do we start with? What do we start with? Oh, well, we already have some fixed expenses. Maybe that's heating, maybe that's electricity, whatever it is. What happens first? Well, it says the word additional, so the costs go up. What happens next? Well, it's not just 6, it's $6 for each and every week. Write the multiplication dot if you wish. So what do we start with? 750. What happens first? Well, we pay additional money for the animals. What happens next? Well, it ends up being $6 for each. Let's not say a week, huh? Let's say per animal. Because after all, we're talking about 1 week. So $750 plus 6 per animal. At most $900. Look, you got a budget. You can spend at most that much money, which means you can spend less than that. Great. You can also spend exactly $900. So there, ladies and gents, is our inequality. Let's go ahead and solve. I'm going to go ahead and use the commutative property, change around the order, and say, hey, that 750 has nothing to do with the number of animals. That's a fixed cost. So let's get rid of that 750 and find out how much was spent on animals. That leaves us with 6 per animal, less than or equal to 150. We're going to divide that into 6 parts. And dividing by a positive does not flip around the inequality symbol. That leaves us with a single A, less than or equal to 25. What does that mean? So the shelter can house at most, you notice what word phrase I chose to use. You could have said 25 or fewer animals to keep their weekly expenses at $900 or lower. That's what I got, guys. I got a challenge coming up. Actually, basically what we're going to do is we're going to start the homework up together in class. Following that, try to ask yourself this summary. Give yourself a real-world example that could help someone understand why at least that word phrase is greater than or equal to. That's what I got, folks. Let's grow.